In question number 6, I have this 1 over sine plus cos equals sine minus cos theta over 1 minus 2 cos squared theta. Now, first of all, there's lots of different ways to do this, and I'm going to show you a fairly efficient way to do this, but it involves recognizing a few identities. In particular, it involves recognizing that cos 2 theta is equal to 2 cosine squared minus 1, and it looks very similar to the denominator on the right-hand side. And cos 2 theta is equal to cos squared minus sine squared. Those are the same identities. If I take a look at sine theta plus cos theta and sine theta minus cos theta, they are, in fact, conjugates of each other. And if I want to use that conjugate, I can use that in the denominator to get sine squared minus cos squared, which again looks very similar to that cos squared minus sine squared. And not only that, it will generate the sine minus cos in the numerator, which is what I want. Okay, I want this factor in the numerator. And if I do that to both the top and bottom, well, at the very least, I've put that factor in the numerator, which matches the right-hand side. So in doing that, I end up with sine theta minus cos theta. That already matches the right-hand side. And this becomes sine squared theta minus cos squared theta. Okay, and so at this point, I can see that the numerators match, denominators are pretty much the same. They're just the backward subtraction of the cos 2 theta. So I can convert the denominator into negative cos 2 theta for both sides and then make it match. I'm going to do this slightly differently, and I'm just going to replace that sine squared with this identity. Sine squared theta equals 1 minus cos squared theta. And what that will do is it will change the denominator on the left to look like the denominator on the right. So it looks like this: sine theta minus cos theta over, instead of sine squared, I'm going to use 1 minus cos squared theta. And then that's minus cos squared. And that's going to be equal to the right-hand side, because when I actually simplify this, it's going to be sine theta minus cos theta in the numerator. In the denominator, I'm going to have 1 minus cos squared, or minus 2 cos squared theta. That now equals the right-hand side identity.